Okay, we have finished two types of loci already. The third one is arguments. Okay, let's start with the simplest example. Okay, let's say argument z equals pi over 3. What do all the points that satisfy this property look like? Okay, can I have some quiet please? Everyone look at the screen. If I draw all the complex number that has argument pi over 3, 60 degrees. You find all the numbers are those that lie on this red line here. Okay, this angle here is 60 degrees pi over 3. Okay, so this is what I mean by the locus of this equation. Argument z equals pi over 3. You understand? All the numbers that lie on this red line, all of them satisfy this equation. They all have argument pi over 3, 60 degrees. Okay, you find that if you look closely, when I draw this red line here, the origin I exclude. Okay, the origin, I'll put a small little empty circle to show that argument of 0 is not defined. Okay, it's not 60 degrees, it's not 0, it has no value. So that's why when I draw this locus, there's always an empty circle. Okay, so I can have different angles. There's this scroll bar here that I can use to change. Okay, I can have other like pi over 2, 2 pi over 3, any angles. Okay, so all these equations all have this form. Argument z minus something equals to a certain angle. Okay, the angle can also be 0, can also be negative. Okay, so these are the different loci that satisfy this equation. Okay, what if it's not at the origin? Okay, you have learned transformation, I can shift the whole thing to the right. Okay, let's have another simple case of that. If I shift right, the equation now becomes argument z minus 1 equals pi over 3. Okay, these are all the complex number. If you go and work out the argument z minus 1 will be 60 degrees pi over 3. Okay, it's like a transformation. Shift right, z becomes z minus 1. Okay, you can, here I have a simple case of a real number. It can be any complex number. Okay, I can shift this point to, let's say, if I have 1 plus I. Okay, zoom out a bit. Then all the locus will still lie in this straight line. But now I don't measure the argument from the origin anymore. I measure the argument from the point 1 plus I. Okay, so the equation looks like argument z minus 1 plus I equals 60 degrees pi over 3. Okay, everyone can see how I get all these forms. Okay, just start from origin, I can do some transformation, shift it somewhere else. The equation becomes like this. Okay, so in general, they can give you any complex number to start with, and they can give you any angles. Okay, so if you want to plot different loci of this form, the starting point can shift anywhere. Okay, and then the angle, you can have any angles between minus pi all the way to pi. Okay, any of these angles. Okay, so all these always have this form. Okay? Okay, so now we know when you draw this locus, it's always just a half line. Okay, what do you mean a half line? That means you stop somewhere at the starting points. It's not y equals mx plus c. You don't go and draw the whole line all the way down to minus infinity. Okay, so that's what I mean by a half line. Okay, you can see this in the definition. Okay, that's all. Let's go back to the definition in the lecture.